Hi, welcome to this video. First we're going to do sorting and then we're going to do visuals of two-dimensional arrays. So the first sort we're going to do is selection sort. So this is an array called A. The size of the array is 10. And we're just going to assume it's been initialized with all of these values: 8, 6, 10, 2, 16, 4, 18, 14, 12, and 20. So this is an array. So to draw the picture, this is an array of integers: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The array is A, which is a pointer to the beginning of the array. And this is A at index 0, which the data type of that is integer. And this is A at index 1, 2, 3, 4, 5, 6, 7, 8, and 9. And since we've declared and initialized it, it has the following numbers or integers are in the array. So A at index 0, the value of that is 8, 6, 10, 2, 16, 4, 18, 14, 12, and 20. So the way that selection sort works is we're going to run by and do a selection sort on this. So selection sort works by starting at the beginning and going through and searching through the entire array to find the index of the smallest element. So in this case, the index is a 3, and then it's going to swap these two values. Then we move to the next one, obviously through a loop. Search through, find the index of the smallest one, which is index 5, and then swap these two values. Move to the next. Find the index of the smallest, which is index 5, and then swap these two. Next, find the index of the smallest, which is this one, and so it's going to stay there. Next, find the index of the smallest, which is index 5, and swap these two. Find the index of the smallest, index 8, swap these two. Find the index of the smallest, which is index 7, and swap these two. Find the index of the smallest, which is this one, and swap these two. And do the last one, which does not need to be swapped. And now we have completed the selection sort. This code is on Canvas, so you can read it and try to change things on it and test it and see how, but that's the visual of how it works. The next one we're going to do is bubble sort. So our array is int A. The size of our array is 5. The values in our array are 3, 10, 9, 2, and 5. Here's the picture of our array: 0, 1, 2, 3, 4. The array name is A, which is a pointer to the beginning of the array. This is A at index 0, which is an integer. A at index 1, 2, 3, and 4. The values are 3, 10, 9, 2, and 5. And now we're going to do a bubble sort. Both of these sorts we're sorting in ascending order, but you could change it and do it in descending order. So bubble sort starts by just comparing two. And if the one on the right is smaller than the one on the left, it will swap them. But in this case, it's not going to swap those. So it moves on to the next one. It's going to swap these, 9 and 10. Moves on to the next one. We'll swap these. 2 and 10. Moves on to the next one. We'll swap these. 5 and 10. And now it has gone through the first pass. So after the first pass, the largest one will be on the end. Now we're going to do the next pass. The next pass, compare, do not need to be swapped. Oops, I accidentally erased my whole array here. Okay, these two, we will swap 2 and 9. These two, they need to be swapped, 5 and 9. And now we have done the second pass, so the next largest will be here. Now it's time to do the third pass. Swap 3 and 2. And check here. They do not need to be swapped. So now after the third pass, the next largest will be here. Now we will do the fourth pass. They do not need to be swapped. So after the fourth pass, we do not need to do a fifth pass because we already know that the first element is going to be the smallest. So that's how bubble sort works. And here is the code for bubble sort, which is also on Canvas. So please take a look at it, and if you have any questions, please ask. The next thing we're going to do is a two-dimensional array. So I'm going to declare an array called A, which has a number of rows. I'm going to have 4 rows and with 3 columns each. So there's a couple of different ways to deal with this. The first thing is I'm going to just write the code to fill it with data by user input. In order to do that, you would need to use a nested loop. So the outer loop would be go through the rows, which would be for int I equals 0, I less than 4, I plus plus. So that would be the number of rows. And then you would nest another loop inside of that for int j equals 0, j less than 3, j plus plus. And that would be the number of columns. And you would prompt, so cout, enter, and cin into A at index I, j. So if you were to trace this code, first you would go to trace the code, it would go from A at index 0 would be the outer one, and then j would be 0. So the first one you would read into would be A at 0, 0. The next one you would read into would be A at 0. J would change, so you have A is going to be 0 and J is going to be 0. Then you do this inner loop up until J completes, and then you go back to the outer loop. So it would go from A at 0, 0 to 0, 1 to 0, 2. And then that would complete one whole inner loop. Because now 2 is less than 3, and then when you change j to 3, 3 is not less than 3, so then you go back out to the outer loop. Then you would start again with A at index 1, 0, 1, 1, 1, 2. Then you would go back to the outer loop again. A at index 2, 0, A at index 2, 1, and A at index 2, 2. Since there are 4 rows and 3 columns, we would complete it by doing the last set of rows, 3, 0, A at 3, 1, A at 3, 2. So that is how you would fill an array with user input, a two-dimensional array. And now I'm just going to draw some pictures of the two-dimensional array. All right, so if our two-dimensional array is int A that has 4 rows and 3 columns. All right, so let's just pretend we have data in there. So our memory map would look like this. Which is A starts here. So we have 1, 2, 3 columns, 1, 2, 3 more columns, 1, 2, 3 more columns, and 1, 2, 3 more columns. So this here is where we start our array, and this is the first row, second row, the third row, and the fourth row. So it's much easier to follow if I put data in here, so I'm just going to start with the number 10. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. And this is A at 0, 0, A, 0, 1, A, 0, 2, A, 1, 0, all the way down to A at 3, 2. A at 3, index 3, 1, A, index 3, 0. A, 2, 2, A, 2, 1, A, 2, 0, A, 1, 1, A, 1, 2. So each one of these is an integer. So A, so you could do int num equals A at 1, 0 plus 20. So it would take whatever value here is A at 1, 0. So A at 1, 0 is 13. Add it to 20 and assign that result to num. So all of these over here are integers. So now let's draw it. There's two other ways you could draw this. One is as an array like this. Okay. This would be row, let's make it a little bigger. So this would be row 1, row 2, row 3, and row 4. And then, so this is row 1, row 2, row 3, and row 4. And then inside, I would have columns like this. Each one has 3 columns. So the values would still be 10. Did I really mess up like that? Glad I caught myself. This is not row 1, it's row 0, row 1, row 2, and row 3. And then in here, this is column 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2. So if I went to A at 1, 1, so you go 1, 1, the value of A at 1, 1 is 14. The value of A at 1, 0 is 13. The value of A at 3, 0 is 19. This is row 3, column 0. This right here, row 3, column 0, is the same as this right here. And one other way to draw this is as a table. So the table has 4 rows. 1, 2, 3, 4 rows. 1, 2, 3, 4 rows, and 1, 2, 3 columns. So this is the same, only this is going to be 0, 1, 2, 3, 0, 1, 2. So if you were to go to 1, 0 would be 13. 3, 0 is 19. If we go to row 2, column 1, row 2, so we go to row 2, column 1, which is right here, it's a 17. Row 2, column 1 is a 17, or row 2, column 1 is 17. So the way that I always remember, the way that you do this is row first, column second, is that they're not alphabetical. I don't know. You got to try to, you just have to remember the way you define it, and the way you access it is by the row followed by the column. The column must be consistent because, as you notice, the columns are the same, have to be the same size always, because the way it calculates how to get to the information is it starts here, and if it wants to get to row 2, it's going to have to count 1, 2, 3 integers, 1, 2, 3 integers, and then it will be at row 2. So I hope this helps you to understand how two-dimensional arrays work and how they're stored. And please take a look at the sample code on Canvas and ask any questions if you have any.